Okay, we're going to go ahead and get started. This is a lesson 11, system of linear equations. And we're going to go through linear systems using the substitution method and the elimination method. Linear systems. We have a set of equations called a system of equations. So basically, when you have two equations together that work, you want to try to find a common solution between the two, then you have a system of equations. The solution that is in the system of equations has to be a solution for both equations, not just one. It has to be both. If all the equations in a system of a linear system of linear equations or a linear system, okay, so you have all the equations, whether it's 2 or 3 or more, they're all a part of the linear system. Here we have two equations, 2x minus y equals 2, and that would be the blue line, and x plus y equals a negative 2, that would be the red line. They both crisscross at a certain point, 0, negative 2. So that point, 0, negative 2, is the solution for both lines. In other words, it's a point that's common to both, where both lines intersect at. So when we solve a system of linear equations and you get one single solution, then you could look at, picture that the two lines crisscross at that single point. And this is known as a consistent system. The equations are independent of each other. In other words, they cross at only one point. And there's only one solution for linear equations. Here we have two parallel lines for two equations. This is our system of equations here. And so they don't intersect at any point. There's no common point between the two lines. So there is no solution. And this is considered an inconsistent system. An inconsistent system. The equations are independent of each other because they don't cross anywhere. Here that we have two equations, x minus y equals negative 3 and 2x minus 2y equals to negative 6. Both lines, it's like one line is on top of the other line, and so all the points on that line are a solution because they're all common. They all share the same solution. So there's an infinite many solutions here. So they would be considered a dependent system. It's like one line is dependent on the other line for a solution. And so there would be an infinite many solutions here. Infinite because there's an infinite number of points that would be on both lines. And both lines go on indefinitely. The substitution method, that's where you have two equations. You solve for one of the equations and then substitute that into the other equation. And normally you want to find a variable that has only one for a coefficient, and that's the one you solve for, and it could be either x or y, it doesn't matter. And that way you don't have to divide a number into anything if you have one. All right, so let's take a look at this first system of equations. And let's see, we want to use the substitution method to work through this. All right, so we have here 3x plus 2y equals 11. And you've got a negative x plus y equals 3. And you want to solve by the substitution method. All right, so that means first thing we have to do is we have to solve for one of the variables. It could be x or y. So here we have a 1x, a minus 1x, and a 1y. So really we have a couple of them we could use. We don't want to use the 3x. We don't want to solve for x or y in this first equation because then you have to divide by 2, and that's more work. So if we solve for y here and apply 1x to both sides, we get y equals to x plus 3. Okay, so we solve for one of the variables, and now step 2, substitute. In this case, we're substituting the second equation into the first. Okay, so it's like, here's our first equation, 3x plus 2y equals to 11. And it's like we're cutting out, since we're solved for y, we're going to substitute y. So it's like we're cutting this y out, and we put parentheses there. So this would be like saying 3x plus 2, and then where the y was, we put parentheses in there, equals to 11. Well, what's going to go into that equation, into where the y was? The x plus 3. All right, questions with that so far? And from here, we want to, step 3, move this down, step 3, simplify and solve. So we would distribute, of course, we would distribute that 2, and there would be 3x plus 2x plus 2 times 3 would be 6 equals to 11. And now we would simplify and solve from here. So that would be 3 and 2, that would be 5x plus 6 equals to 11. And we just keep right on going. Minus 6. And we get 5x equals to 5. And divide by 5. And we get x equals 1. Okay. Now we're not finished here, because now at this point we solve for x, but now we have to substitute. This would be step 4. Substitute the x solution into either equation. Okay, you could put it in either one of them to find y. And so let's say we substituted that into the second equation. So that would be negative x plus y equals 3. into, so we substitute x solution into one of the other equations. Okay, so since x equals 1, it's like we're cutting that x out, right? Because we've got to put 1 in there. Put parentheses. So this would be negative, parentheses, where the x was, plus y equals 3. And what's going to go in there for x? The 1, right. We put 1 in there. Now, if this was a negative number, then you'd have to have minus for the equation, and then minus, whatever that number is. You have to count both of them, one negative for the equation and one negative for the solution. So you want to be careful with that. And so we get negative 1 plus y equals 3. And now the last step, we're going to solve for y. And so we apply plus 1. And we get y equals 2, 4. So our solution here, right, would be x is 1, y is 4. Now, there's one more check we want to do here, and that's to check our solution with the other equation. In other words, since we used the second equation to find y, we don't want to use that same equation to check it. Since we checked it with the second equation, since we found y with the second equation, you want to go ahead and check it with the other equation. In this case would be the first equation. So we're going to use the 3x plus 2y equals 11 as a check. And so we're going to substitute in our x and y. So it's like we're putting here, cutting out the x and the y, putting parentheses. Okay, and what's going to go in there for x? The 1. And the 4 is going to go in there for y. And if it checks, what should we end up with? Yeah, at both sides should equal, right? So this would be 3 plus 8. Yeah, that's going to equal 11. So it checks. Okay, so but our answer is 1, 4. So if we were to graph these two lines here, they would intersect where? One, 4. Right. X is 1, y is 4. Okay? All right. Questions with that? So they may even ask for you to put it in curly brackets, 1, 4 like that, So you may see that on the homework, and they have it parentheses and brackets in there. Okay, questions. All right, let's go back to our PowerPoint, and now we're going to take a look at the elimination method. Okay, and this method uses multiplication and addition. Instead of substituting in, you try to eliminate either the x variables or the y variables. Whichever one you eliminate, the coefficients have to be the same, but opposite signs. Okay? All right. So here we have an equation, 3x minus 4y and 2x plus 3y equals 1 and 2x plus 3y equals 12. All right, let's see how that looks applying the elimination method. Okay, so we're going to solve for 3x minus 4y equals 1 and 2x plus 3y equals to 12. And so we're going to solve using the elimination method. Okay, solve, and we're going to use the elimination method. Okay, which means when you're looking at these, you want to look at, again, the easiest possible way to eliminate it. Either using, it helps to see if there's anything that has opposite signs, like the y's have opposite signs, negative and a positive, but your coefficients are different. So we want to get them to the same. So what we do here is we put, I'm going to rewrite this again, 3x minus 4y equals 1 and 2x plus 3y equals to 12. And we're going to, step 1, eliminate, in this case, the y's. But it doesn't have to be the y's. It could be the x's by multiplying a number that provides the same coefficient for both y's, but opposite signs. Okay, so in this case, if we want, let's see now, a way you can look at this is, all right, if we were to multiply 3 times 4, well, what's 3 times 4? Like if we were to multiply 3 here, right? 3 times 4, what's that? 12. And then 4 times 3, that's 12. So we can't just multiply the 3 times the 4 in order for both equations to balance. You have to multiply all the terms times 3. And so this one here, you'd have to multiply all the terms times 4. So that gives you 3 times 3, that's 9x, minus 12y equals to 3 times 1 is 3. And then 4 times 2, that's 8x, plus 12y equals to 4 times 12, that's 48. All right, questions with that? Okay, the next step is we're going to add or subtract coefficients, and the last numbers on the other side to eliminate the y's. Okay, so that would be a positive 9 and a positive 8, positive 9x, positive 8x, that would give us a what? 17x. And you got negative 12 and a positive 12. Well, they cancel out, right? That's like saying 0y. But we don't normally write 0y. We just leave it blank, right? But that's really what we're doing. And that's the whole idea, to eliminate the y's. And then 48 plus 3, that's 51. Okay, now step 3, we're going to solve for x. So we couldn't solve for anything before because we had two variables, and we can't solve using two variables. But now we've eliminated the y's, so now we can solve for x. So we divide both sides by 17, and we get x equals what? Sydney? 3, right. Okay. Now we do the same thing at this point to find y. We substitute the x variable back into one of the equations and solve for y. Okay, so we could choose either one. Doesn't matter. So we're substituting back into x. So let's use the second equation again. 2x plus 3y equals 12. And we go ahead and we substitute the 3 in for x. So that'd be 2 times 3 plus 3y equals 12. So that'd be 6 plus 3y equals 12. And we're going to apply minus 6. And we get y equals to what? 2, right. Divide by 3. We get y equals 2. Okay, questions with that? All right, and so now for the last step, 5, we check it by, again, substituting the x and y variables into the other equation. Since we used 2x plus 3y, we're going to use the other equation, 3x minus 4y equals 1. And so we're going to substitute both. So our solution here is 3, 2. So we're going to check that. So that'll be 3 times 3 is 9 minus 4 times 2. Okay, so we get 9 minus 8. Sure enough, that checks. So that'd be 1 equals 1, and it checks. So our answer is 3, 2. Okay, questions with that? Okay. Okay, so we look and see that the 3, 2, the lines cross. If we were to graph it, the lines would cross at 3, 2. Okay, questions with that? All right. We want to solve this next one here. 3x minus 2y equals to 4, and negative 6x plus 4y equals to 7. And again, we're going to use the elimination method. Okay. Well, looking at this, really, you have your x's have opposite numbers, your y's have opposite signs. Your y's have opposite signs. So what do you think we could multiply this first equation? Yeah, 2. So go ahead and multiply 2 into the first equation. And so we're going to go ahead and multiply 2. Okay, go ahead and multiply 2. And then the second equation, you're not going to do anything. And then let's see what happens. Okay, go ahead and try that. And I'll give you a minute or so to work on that. And then I'll put in some input on that to see how you're doing. Okay, well, what happens? Yeah, the x's cancel, right? They go to 0. The y's also cancel. They go to 0. And 8 and 7 is 15. So that's as good as saying 0 equals 15. Well, can 0 ever equal 15? In other words, are both sides equal or not equal? They're not, right? So what would we say about our solution here? Do we have a solution? Or it's no solution. If we were to graph this, what would it look like? Two parallel lines, that's right, where they don't cross anywhere. Okay? Questions with that? All right, so let's see how that would look graphically from our PowerPoint notes. They would look like two parallel lines, like we said. And so this would be called an inconsistent system. It's inconsistent of any solution. Okay? Questions with that? And so, you know, in set notation, you would use a 0 with a line through it. Okay? All right, questions there? Okay, here's another problem. 8x minus 2y equals 4, and negative 4x plus y equals 2. All right, and so here we have 8x minus 2y equals to a negative 4 and negative 4x plus y equals to 2. All right, now if they don't tell you if they don't specify which method to use, you can use either one. Okay, let's say that, but if they do tell you to use the substitution method, you have to use that method. If they tell you have to use the elimination method, you have to use that. But let's say they didn't tell you. Okay, if we wanted to use substitution, okay, which variable would be the easiest to solve for? X or y in the first equation or x or y in the second equation? In other words, which variable would be the easiest to isolate? To where the y in the second, that's right. So, because it's only a 1 and we don't have to divide everything and get fractions, right? And so we solve for y. So we apply a plus 4x to both sides, and we get y equals to 4x plus 2. So up here at the top, I'm going to use the substitution.
Does that mean negative 4x plus 2?
Oh,
never mind.
No, yeah, because it's, yeah, we're adding, right? Okay, so now we've got y equals to 4x plus 2, right? Now what do we do? We are using the substitution method, right? We took the second equation, solved for y. Now what do we do with this 4x plus 2? Plug it into where? The y for the first equation, right? So it's like we're taking this second equation and we're saying 8x minus 2. And then where the y was, we put parentheses in there, equals to a negative 4. And what's going to go in there for y?
4x plus 2.
Right, the 4x plus 2. And so we distribute that 2. And so this is going to be 8x minus 8x again. Negative 2 times negative 2 is going to be a minus 4 equals to a negative 4. Well, what happens to the x's here? They cancel, right? They go to 0. So that's right, because both sides equal, you have an infinitely many solutions. Okay? And in that case, what you would do is you would write, you see how we solve for y here? See how we solve for y here? Our solution would be x, instead of xy, right? We put x, comma, and then we put what y equals, 4x plus 2. We put the equation in there for y in terms of x. And from that, we have a dependent system. Okay? This would be known as a dependent system. All right. So graphically, that would look like what?
2 lines on top of each other.
That's right. 2 lines on top of each other. So really, it just looks like one line, right? All right, good. Questions with that? Okay. let's take a look at some other problems from the homework. And let's see. Here's one. 4x minus 5y equals to a negative 11. And 2x plus 1y equals to 5. And you're going to solve using the substitution method. Okay, solve using the substitution method. And I'm going to have you decide which one to solve for. All right, go ahead and try this. Well, if I were you, I would isolate the y in the second equation because you don't have to divide anything. Makes it easy. So now we're going to substitute the y into the first equation. So it's like we're cutting that y out and we put parentheses there into the first equation, and then we're going to substitute the minus 2x, or in this case we're putting it, let's do it over here. The negative 2x plus 5. So we get 4x, and a minus 5 minus 2 is going to be plus 10x minus 25 equals to a negative 11. And so we get, it's not enough from here, we solve, right? And so that would be plus 25. $14x. So we're actually subtracting here, right? And so that would be 14. And so x equals 1. All right, how do we do with that? Okay, so now what?
Solve for y.
Right, solve for y, and how do we do that? Plug in x back into one of the two equations. Doesn't matter which one, it's either one. Okay, so I'm going to go ahead and plug it back into the second equation. All right, so that's going to be 2. We're using 2x plus 1y equals to 5. And so we're going to put 1 in here for x. And so that would be 2, right? So we're going to subtract 2 or apply minus 2 to both sides. We get y equals to 3. So the solution here is what? For an answer. 1, x is 1, y is 3, right. And so which equation do we plug it into to check it? Since we use the second one to find y, right? If you check it with the same equation, it may end up coming out checking right, but in order to make sure that you got it right, you want to go ahead and plug it into the second one. Because if your answer is wrong and you check it with the same one that you got your solution from, it may come out showing right, but in fact it's not. So you always want to use the other equation to check it. 4x minus 5y equals 11. And so we put 1 in here for x, 3 in here for y, and so we get 4 minus, let me make sure that's the right equation. Oh, that's negative 11. Okay, no wonder why that didn't look right. 4 minus 15 equals to negative 11, so negative 11 equals to negative 11, and it checks. Okay? Questions with that? Okay, let's try this. 4x plus y equals to a negative 23. And here we have x minus 2y equals to a negative 17. And you're going to solve using the elimination method. I'm just going to abbreviate method. Okay, solve using the elimination method. Now, looking at the x's and looking at the y's, what would be the easiest to eliminate? You want to see if it has opposite signs. That might be a good thing to start with. So, what would we want to eliminate? The y's, right. So I'm not going to tell you what to multiply here. Go ahead and try that. Okay, how are we doing so far? So if you multiplied the first row, the first equation times 2, that would give you a positive 2y and a negative 2y, and the y's would cancel. Okay? Since the signs were already opposite, it would be easier to eliminate the y's. You could have also eliminated the x's, but then you'd have to multiply a negative and a 4 times the second equation in order to do that. So it's easier to try to eliminate the y's in this case. And so now we solve for x, and we get x equals what? Negative 7. Okay? And so now you can substitute negative 7 in the first or second equation. Either one, doesn't matter. So I'm going to use the second equation. So this would be negative 7 for x minus 2y equals to negative 17. And so we apply plus 7. Negative 2y equals to a negative 10. And so y is going to equal what? Yeah, positive 5, right? Because you're going to divide negative 2, divide by negative 10, you get positive 5. Okay? And so this would be negative 7, positive 5. And, of course, you want to check it. Since we use the second equation, we're going to use which one to check it with? The first equation, right. Okay. All right, questions with that? And you can use your calculator, too, to check it. That's not a problem. All right, any questions with that? Oh, come on. What are you doing here? All right. Okay, now let's say that we have x plus 6 over 5 plus 2y minus x over 10 equals to 1. And the second equation, we got x plus 2 over 4 plus 3y plus 2 over 5, and that equals to a negative 3. Okay. What would help make our lives, and let's say we were going to use the elimination method. Use the elimination. Okay? So, what would help to make our lives a lot easier in this problem? Get rid of the fractions, right. So in this first one here, x plus 6 over 5, let me move this over. Two y minus x over 10. Okay, what can we multiply here to eliminate the denominator or denominators for this first equation? Well, we got a 5 and we got a 10. So what would multiply? In other words, what would be the least common denominator we could use to multiply out all the denominators?
Make the 5 a 2 or the 5 a 10?
Yeah, you'd multiply everything times 10. You would multiply all terms by 10 to eliminate the denominators. Okay, so you got to multiply 10, but when you do that, you want to put parentheses around the numerator. Multiply times 10. So you got to multiply everything times 10, whether it has a denominator in it or not. So 5 can go into 10 how many times? 2 times, and then we distribute that. And we get 2x plus 12. Okay, and then we go ahead and cancel the 10s out, and everything cancels. So that'll just be 2y minus x equals 210 times 11 is 110. And from here we simplify. Okay, so we got 2x and then minus 1x, that'd be 1x. And plus 2y. And what would we do with that 12? That's 12. Yeah, you want to move it over to the other side, apply minus 12 to both sides. Okay, and so that gives us x plus 2y equals to what? 98. Okay?
You want to change the 1 to an 11? Start out with a 1 equals to a 1.
Okay, hold on, let me back up here. Oh, that should be a 1, you're right. So this should be a 10. That's better. This should be a 10 here. And so that makes this a minus 2. Okay? All right, now we got to do the other equation. So this first equation turns out to become x plus 2y equals to a negative 2. All right, let's see what we can do with the second equation. And I'm going to have you try the second equation. The x plus 2 over 4 plus 3y plus 2 over 5 equals to 3. Okay? And let's put parentheses around those numerators. Okay, find the number that will multiply out that denominator. And multiply that number times that. All right, go ahead and try that. Okay, what number did you use to multiply all three terms? In other words, think of it in terms of the least common denominator. 20, right. So we got to multiply 20, multiply 20, multiply 20. All right, questions with that? And you cancel and then distribute. And then simplify. Well, we got to move that 18 over, right?
Three was a negative.
A 3.
At the end, and 6.
Well, that was a negative 3. Okay. That should be negative, so that's a negative 60. That's negative. So that makes that a negative 78. Okay, so our two equations are 5x plus 2y equals to negative 78, and x plus 2y equals to negative 2. Okay, now what? We're going to use the elimination method. So which equation, which variable would be the easiest to eliminate? The x, right. So that means you'd have to multiply you'd have to multiply the second equation by what? Right, because you've got to get the signs to be opposite. Okay, so this will be 5x plus 12y equals to negative 78. And this will be negative 5x minus 10y equals to 10. All right, questions with that? So the last term is going to be a positive 10. So here the x's cancel. And you got positive 12, negative 10, that'd be 2y. And here you got a negative 68. So we're going to divide both sides by 2 and we get negative 34. All right, questions with that? All right, now what? We got y. How do we find x?
Plug it in.
Right, plug it in. Easiest to plug it into the second equation, right? X plus 2 times a negative 34. So that would be back to x equals to x minus 68. And so we apply plus 68. That's a negative 2. And we get x equals to 66. So our answer here is 66, negative 34. All right, questions with that? Okay. We're going to take a break, and then we'll go on to the next lesson.